go to page 130 in your journal to start section 5.2 and copy down the definitions for simplest form of a radical, conjugate, and like radicals. You'll see the definitions appear at the side. You can also review your core concepts. These are all the properties of exponents that we reviewed in the previous video. Then I want you to go to your notes packet. Looking at example 2, it says use the properties of radicals to simplify. So I see the cube root and cube root being multiplied. So I can write this as the cube root of 12 times 18. And that's the cube root of 216, which we know from previous examples equals 6. Looking at part B, we can see the fourth root of 80 over the fourth root of 5 is going to be the fourth root of 80 divided by 5. And what's that? 80 divided by 5. That's the fourth root of 16. And we know this equals 2, because 2 to the fourth power is 16. So take a look at example 3 on the next page. For example 3, we're just writing this in the simplest form. So this is like reducing square roots and simplifying those, but now we have cube roots and fifth roots. So it's a little bit more complicated, but we know how to do this. We can split up 135 into the cube root of 27 times 5. And we want to pick one of the numbers that is a perfect cube. So I know that the cube root of 27 works out nicely. So that I have the cube root of 27 times the cube root of 5. And that's just going to be 3 cube root of 5. You can write a little neater than I can. And then for part B, we're going to do the same kind of thing. We're going to say, okay, I can't simplify 7 divided by 8, or the fifth root of 7, or the fifth root of 8, but I can multiply both of these roots by the fifth root of 4. The reason I can do this is because I know a fifth root. I know that 2 is a fifth root, so 2 to the fifth is 32. And 8 times 4 is 32. So I know I can pick something nice to make this problem a little bit better. So in the top, I'm going to get the fifth root of 28, because that's 7 times 4. And in the bottom, I'm going to get the fifth root of 8 times 4, which is 32. And I can say this is the fifth root of 28 over 2. So whenever we have something like part B, we want to get rid of the fifth root in the bottom. And so we want to multiply 8 by a number that gets it to equal a perfect fifth root. And this would be our final answer. Looking at example 4, we want to write this in simplest terms. So we want 1 over 5 plus square root 3. We want that to be simplified. We don't like square roots or any roots in the denominator. So we can multiply the top and the bottom by the conjugate, which was one of the definitions that you got. So if we multiply the top and the bottom by the conjugate of 5 plus square root 3, we get 5 minus square root 3 in the top. And then you would have to FOIL, think FOIL, for this bottom part. And the middle term cancels out. So I would get 25 minus 5 root 3 plus 5 root 3 cancels. And then minus square root of 3 times square root of 3 is just 3. From here, I can say, okay, 5 minus the square root of 3 over, what would that be? 2. Oh, 22. What am I thinking? And this would be my final answer. If you're wondering how we got the 25 minus 3, I multiplied these two. I FOILed these two together. Okay. And last but not least, I want to look at example 5. Example 5 is just adding and subtracting like radicals or roots. So if I have the 4th root of 10 plus 7 times the 4th root of 10, the 10s are the same and the roots are the same. But technically there's just a 1 in front of this. So the way your book's going to write it is 1 plus 7. You're going to take out those numbers times the 4th root of 10. And that's just going to equal 8 times the 4th root of 10. And that's how we simplify that. Part B, same idea. So what two numbers do you think we're going to add together? Yeah, 2 plus 10 times 8 to the 1/5. And that's going to equal 12 times 8 to the 1/5. And we can just leave it like that. You can put parentheses if you want. Now for part C, I don't see the same thing here. I see the cube root of 54 minus the cube root of 2. So I don't see how that's the same. But we have to simplify the cube root of 54 to be the cube root of 27 times the cube root of 2. Because 27 times 2 is 54. And then I still have minus the cube root of 2. Now, I can take out, this is like a 1 here, and we have something in front of here. So this simplifies to be 3 cube root of 2 minus cube root of 2. And now I can pull out the 3 minus 1 times the cube root of 2 equals 2 cube root 2. And that would be our final answer. Now tomorrow in class we'll look at the monitoring progress and the online problems. If you still need help or have questions, look in your book and try to follow along with these examples.